Hey everybody, welcome back to the Metal Mill 52 workshop. For those of you that are looking for some live steam content of building a live steam locomotive, you came to the right place. The project we're working on is building an LBSC Tich locomotive. This is a little 040 3.5-inch gauge locomotive. In this week's episode, because I was waiting on new tooling, which I'll describe in the episode, I'm going to show you how to make this 3/16-inch PM Research ball valve. I had previously made this 1/4-inch size one to use as the blower control, and it occurred to me that the smaller 3/16-inch one would be a lot better. So if you'll stay tuned, or would look a lot better on the locomotive. So if you stay tuned with me for this, will probably be about a 20-minute episode. I'll show you some neat stuff about how to make this special style of blower valve. Also, I cover a new tool that I got for the shop that I'm very excited about that will help me make progress with the superheater and that kind of thing. So hope you enjoy it. Please give me a thumbs up. Please subscribe. Please help pass the word on the channel. I sure appreciate it. Thanks, everybody. And a special note, today is Dr. Martin Luther King Jr.'s birthday, and having grown up in the 1960s, a lot of his message resonates with me. I don't get into political stuff, but it means a lot to me, and I hope that you would take a few moments and reflect on the impact, the positive impact that he had on our nation and on relations and equality for people throughout the world. So thanks again, everybody. Hope you're doing well. Thanks for being here. I think this will be a short episode, but what I'm going to do is show how to make a jig for the small 3/16-inch ball valves that you get from PM Research. I've never made one before. I've made a bunch of the 1/4-inch and the 5/16, but never the 3/16. And now that I see the size of the fittings and so forth that come with the Black Gates kit for the Tich, I definitely need to make these. So what I've done is made the initial dimensions, and I've got the 1/4-inch aluminum that I used for the street L jig. So I'll make that in this episode. Alrighty, folks, here's a finished jig for these cool little 3/16-inch PM Research valves. It's nothing fancy at all. Just two pieces of 1/4-inch thick aluminum, 560 thou wide. And let me show you the only interesting part, I guess, or tricky part, is what I used was a 23/64 drill, which is just large enough to clear this hexagonal shape of the actual part, if you can see that. So, and then I go down 280 thou down and drill about halfway, flip it over, drill about halfway this way, and then go to the center and come in. Same drill, 23/64. And as you can see, I did mess up this one. I didn't actually, I don't know what I was doing. I got off on the DRO or something and didn't do it in the center. It won't affect the usefulness of the jig, really, so I'm not worried about that. But let me show you the cool pattern that you get when you make those cross drills. As you can see, it makes a nice little holding area for the drill, or for the part. And the one in the center, if it were on center, come down deep enough to accommodate the ball. So in this case, it was like 440 thousandths that you want to make your drill. And then after you get done, you're going to have a little flash or a little swarf that you got to clean up. What I really like to use is my Dremel. I've got this little burring thing on it. It's a 1/8-inch deburring stick, basically. So I use that to clear out the inside and give it a good fit, and then you're good to go. You just put this together, and you clamp it in your mill vise, and you machine your valves how you want them. Hope that's helpful. A matter of fact, after I got done filming that last segment, I played with it a little bit more, and you could see there was a little bit of gap, a little looseness. So what I did, I took the thing apart, and I used my grinder, that little carbide burr on the Dremel as I was showing, and just rounded out a little bit more where the little bulbous part of the body, the valve body, is. And now, as you can see, the halves are able to close tightly together. So I think we're in good shape there. Anyway, hope this is helpful, everybody, and look forward to catching you up next time. I'm still working on the Tich. Ran into a little setback, so I'll talk about that in more detail later. And while I'm waiting on other things for my LBSC Tich project, I thought I'd make an extra 3/16 inch ball valve, and I've sketched it up a little bit. This is the John Baille style that I've talked about before. Matter of fact, I made a blower valve just like this before, and now I want to make another one, a smaller one, using the 3/16 inch body. I happen to have a set of the castings here. This is what you get. You get the castings themselves, some 5/16 inch hex stock to make the little bonnets out of. You get some brass, 1/8 inch brass stock to make the valve. You get a little hex stock to make the locking nuts for the valve stem. Get some handles, some very cool little castings, and some other hex stock here that is for the packing nut. And here's the packing material. Here they give you a little piece of Teflon. You pick it up, pick it apart, and make little strands that you can put in. So it's nice stuff. I've made these valves before. I've never made a 3/16 inch using the John Baille style before. So first thing I did a few weeks ago, I took some aluminum and I made a holder for this. I think I've showed this before. If not, I'll insert that video into this, but it's about a little 3/4 inch by 1/2 inch by 1 inch roughly block of aluminum that you drill out and then use a Dremel to grind out so that it makes a good holder for the ball valve, the casting itself. So I'm going to go ahead and machine this. I'm going to put it in the middle and then center and then drill through basically 3/16 inch 40 on all three sides. And first step for this thing is to use an end mill and get a nice flat surface for each of the three places that we're going to be drilling and tapping. Once the drilling and tapping are complete, this is what the little casting looks like with the 3/16 inch 40 tapped all the way through and through the top. And this is the little aluminum. Probably maybe a good idea to make these out of steel if you're going to make a lot, but I've used the aluminum and had good results. I think I covered making these in a different video. If I didn't, then I'll insert those segments here as well. It's not rocket science, it's pretty simple. But that's a nice little delicate fitting, and I think it'll look nice on the Tich if I use it. I had a pretty good stopping place for the night. So here's the top part that is drilled, and it's got the conical receptacle in top so it can accept the connecting cone, and with the steam supply. And then this part right here has got it's drilled and tapped for the 5/32 40 inside for the blower stay, quarter by 40 on the outside, and then there's a 3/16 by 40 section, which is of course screwed into the body. And what I'll probably do is silver solder that together and the top part together before I move forward. And then the next major piece to make is the bonnet. So that's out of 5/16 inch hex brass. So that'll come next. I'll get that teed up and probably work on that tomorrow. Alright, making the 3/16 inch angle valve. Before I go any further, I just bought this a little torch. This is a import model, and I'll do more about this later when I cover the brazing. But I've got it set up, and I've never used something like this before, so I thought I would try it. And as you can see, I've got some flux, some black flux put on the valve. There's the black flux, and I took the fittings apart, put the black flux in, and everything's carefully cleaned. And for an initial try, I'm doing it Kozo style. I've got my Safety Silv 45 little pieces that are cut and just stuck in there at the joint. So I'm going to try. I'm not going to video this because I'm using my iPhone, And I do have the coil of safety sylphs standing by just in case those things fall off. I've got my little scratch rod too. So about to give it a try and see if I can make a nice silver solder joint with that, with the little torch. I'll bring you back and show you what it looks like. Anyway, looks like I got a pretty good joint there using the little torch. Very fast. Let me show you the flame there. Very fast to heat that up with the oxygen. And I actually did daub on a little bit extra of the silver solder there on this side right here. But I can clean that up with a tap if needed. But pretty excited about that. I'll do more on it later. Thanks. Okay, back of hopefully finish up the 3/16 inch PM Research angle valve. You can see I got a fantastic silver solder job there. I did run the thread die, the 1/4x40 die on it just to clean up the threads a little bit, but that's all solid. Yesterday I tried to make the bonnet and I well, most of it came out okay, but as you can see I kind of screwed up the end of it. So I'm going to remake that today just to cover it real quick. The critical thing is 2 points. You can get all the dimensions and everything off the plan, so I'm really not going to spend a lot of time on it, but I learned a couple good lessons yesterday. Critical thing is to make this undercut as big as they talk about. You can see the dark section there. It's supposed to be 3/32 inch wide, and then the diameter here is 156, which is a 32 thou, deep removal there, or 15 thou on each side. So it's pretty good undercut, and you really need that to make a good complete contact and seal with the bonnet and the rest of the body. And the other major point is most of the work happens from this side, what I'm calling the A side here. The drilling through and then the drilling and again and tapping and all that stuff. So I'm going to do all that stuff first on this side and then flip it around, and I can finish by turning this part to diameter, threading the outside of it 832, and then putting the little radius. So I'll show a couple of quick excerpts about that. Can't stress enough how important it is to get this undercut to get a good seal. So I just spent a little extra work on it, just mic'd it. Of course I moved the mic. It was like right at 156 a second ago. 159 there. Alright, but 157. So I think that's good, but good pronounced, and wide undercut. It's pretty critical for give the space for this thing to seal once the threads are on. So right now I'll put the threads on while it's still solid, and then I'll do the drilling and tapping. Just completed the bottom half of the bonnet, and I always do a test fit on there so you can see the importance of that undercut. It makes a nice tight seal. I can feel it. There's no wiggle there whatsoever. So I'll take the valve off. I'm going to soak this again in case you're wondering how ugly it looks. I'll soak it again in the pickle, but wanted to have it available for this. So I've also filed down these edges here, so now I can take it out and reverse it. The blank is just a little bit over a 1/2 inch long, which is the finished length. So I'll just need to put it in position and leave enough sticking out for the top part, the pretty little bell shape, and then I'll threading the outside of the top, and let's see. Oh, and yeah, of course, facing it across to the exact 1/2 inch length before I go any further. I'll show you that. When I flip it around, since there's not much material being held by the hex collet there, I put the number 44 drill in, and I use the drill chuck just to keep it aligned. Could be really easy for that to get off center. This thing works remarkably well, and I should have pretty good alignment there with, this is the non-critical side, but you still want to have the alignment as good as possible, and this should help. Okay, there's pretty much the finished top part of the bonnet. Just wanted to show, I used a little form tool. Whoa, lighting's terrible there. But yeah, I used the form tool to give it that nice little bell shape. Pretty happy about that. I'll pull it out and show you the finished product in a minute. Use an 1/8 inch stainless steel for the spindle. First put the little point on it and then I threaded at 540. Well, I filed it down a little bit and then threaded at 540 for 5/16 of an inch, as you can see here. And after you thread it, it's a good idea to leave your point cutting tool in the same orientation so you can come back and clean that up. So that's what I've done. I've just cleaned this up. Now I can file this burr here, take it out, reverse it, and work on the back side. And now with the other half of the stem, spindle rather, I started out with only about 1/4 of an inch sticking out. I turned 1/8 of an inch down to 70 thou, and I just threaded it with the 172 tailstock die holder. So that's good to go. Next thing I'm going to do is turn this portion down, actually the next section, 3/32 of an inch of it, down to 80 thou, and then file that square. I'll bring you back for that. Hey folks, I'm actually using my OptiVisor here to show you first of all, how useful they are, the good magnification, and also hopefully you can see the little square I filed, the square shape on that. You can see the threaded part, that's the 172 thread, and then the square file, that'll be for the handle. Also, the beauty of this, of turning it down to 70 thou first, now I've got my DRO zeroed basically for that diameter. So now I can pull it out, and I'm going to do bit by bit. You don't want to do the whole, there's about 1/2 inch of spindle remaining that needs to be turned down. It'd be crazy to whip all over the place, but I'm going to do about 1/4 inch at a time, maybe not quite that much, but just to get it down to the 70 thou, and then I can file it smooth. So here's what I was talking about. From the little filed square part down, I did about 1/4 inch, slightly less than 1/4 of an inch, and it's turned down to the 80 thou finished dimension. So now I can pull out a little bit more, same thing, keep repeating until I get down to the threaded area. Okay, there's the next to last section of the spindle turned down to the proper diameter. Did just about this much width, and as you can see I used this file here just to smooth out the last little bit of it. So now I can pull it all the way out to the very end there with the threaded portion. Yay, there's the finished spindle. You can hardly see the filed square portion on it, but it's there. So I'm about ready to take it out. I'll show you what it looks like when it's pulled out. I'm going to stop for tonight, but I made the nut that holds the packing in and the nut that holds the handle on. Those are simple. This is out of 3/16 inch brass hex, and this is out of 1/8 inch hex brass. So they're done. Only thing remaining for this thing is to fit the handle. It's kind of late and cold out here tonight, so I'm not going to do that, but it'll be drilling a little hole, tiny little hole, and then filing it square, and I'll cover that tomorrow. And the last step in finishing the globe valve, you can see the contrast. This is the new one, the tiny 3/16 inch compared to the 1/4 inch one here. The last step is putting a hole in the handle. The PM Research folks, what they do is they have you knurl the handle, and then you just put a hole and just force it on, which works fine. And what I like to do though is file a flat, and then what I need to do, usually with the larger ones, I have a small file that I can drill a hole and then file this whole square. I don't have a file that small here, so what I'm going to do, well, first I calculated the size. If I drill for the 80 thou stem, the flat sides are about 56 thou each. So I need to drill a hole about that size. I can use, I think it's a number 54 drill here that has 55 thou, so it's just slightly undersized. And then what I'm going to attempt to do is to use this little homemade broach. I took a 1/16 inch drill bit and ground away the sides here to make a little bit of a broach that you can see. So we'll try to broach the sides, the corners square with this, and then we can remove the... Happily it turned out that the broach was, although not a bad idea, was not sufficient to clear out the square, so I ended up using my little files after all. I do have some tiny ones, and I got a nice fit there for that handle. You can see the nut on the end. When all is said and done, I'll put a drop of Loctite on that nut. I did put some Teflon in the center there for the packing, and I put the nut on. That's why it's not secured home all the way. But next step is I'll take this apart, and the parts that are silver soldered, I want to let those soak in the pickle a little bit more, and I'll probably paint the ball a black color, some black Rust-Oleum, just so it'll kind of match the bottom of the sight gauge, so anyway, I'm very pleased with it. Let me show you. Here's the 3/16 inch. You can see how much smaller it is than the 1/4 inch size one. So very pleased that I went ahead and made this. I think it's going to look a lot better on the Tich. Thanks for watching, everybody. The neat thing is, let me show you one more kind of a teaser. What I plan to work on the rest of this week is silver solder, actually brazing, I should say, this part together. This is the superheater, and the little torch should do the job on this. I will practice a bunch and be working on that this week, and I'll bring you back and show you when this whole assembly is complete. Hopefully I can braze this stuff and with the pieces in the same relative position, and then I'll have to probably re-anneal these tubes together, and I can silver solder the fittings on. But plenty of time to do that later in the week, and I'm excited about it. So please, if you have any questions, please do ask me. If not, just please give me a thumbs up and let me know you watched, and I appreciate that, and I'll see you next time. Take care, everybody.